Hey, Applied Pre-Cal. This is going to be the last part of systems of equations. We're going to use elimination again, so we used it before, but this time we're going to use it to show some properties of systems. There's some really weird situations that happen sometime. Intentionally, we haven't shown you any of them yet in your practice, but we're going to see them with a couple of examples. The first one shows up with this type of example here. So it looks pretty harmless. It's some sort of system. We know that because we have a function and we have a brace, and there are two equations in that brace. So there's a system of these two equations. What we should do now is we can either graph, we can substitute, or we can eliminate to figure out what those values are going to be. Now, it's already set up for substitution really nicely because we've got one variable isolated. So you could do that if you wanted to. If you have Desmos open, you could even punch both of those equations in and you'd be done in about 5 seconds. But for the sake of practice, we're going to use elimination, which means we have to rearrange one of these equations to work a little bit better for us. And in doing that, we should be able to solve for our values. So let's try that. Let's set up, let's try to eliminate 2x. I've already got 2x on the left side. I'm going to move my 3y over and my negative 10 over just so that it looks a little bit more coherent. My y's get together much better, and my constants also get together a little bit better as well. Okay, so by rearranging, my first equation is still the same, 2x minus 3y equals 8. My second equation becomes 2x minus 3y equals 10. I've chosen to subtract my second equation. The reason for that is my 2x's will cancel out. So 2x minus 2x gives me 0. That's great. Negative 3y minus negative 3y, so that means it becomes a positive. It means I get 0. That's a little bit odd. And to be concise, 8 minus 10 gives me negative 2. You realize there's an issue here. We set out to eliminate one of our variables, and no matter what we do, as it turns out, we're actually always going to eliminate both variables, which means I'm solving for nothing. Not only that, I get a false statement. This is the worst thing in math. Whenever you have an equal sign that is invalid, it's an atrocity. You can't have that. 0 does not equal negative 2. That is total bogus. So something crazy is happening here. This is one of our properties of systems. This is a strange situation. Because you get this weird situation where you get no possible solution, it means that these two lines never intersect. They might be parallel lines, and that's possible. You could have a system of two parallel lines, but if they never intersect, it means that there are no solutions. Okay, that last example sucked. It's a really weird situation. Let's try elimination with a slightly different example. So I've got a new system. This system is called g of x, and the system has two equations in it. I've got 2x plus y is equal to 15, and I've got negative 6x minus 3y is equal to negative 45. Again, you could use substitution, you could use graphing to solve this one. I'm going to use elimination just so that we have more practice with it, and I'm going to try figuring out what my x and my y values are going to be. So let's see, let's get rid of x again. X is usually pretty easy to work with, the first one that we see. I've already got a negative 6 on the bottom here for my x value, so I'm actually going to multiply everything on the top by positive 3. That way I end up getting a 6x on the top, and the two of them can cancel each other out. So let's set our equations up that way. They're already arranged properly for us, so I don't have to rearrange anything. I just got to multiply the top by 3. So just like with elimination part 1, I'm going to set the equation up the same way as before. We're going to solve it the same way as before. I just wanted to see what it looks like before I actually do the multiplication. So the only multiplication goes into that first equation. We're going to multiply everything by 3. Okay, and in doing that, I end up getting 6x plus 3y is equal to 45. And now I'm going to add my second equation to that. So 6x minus 6x is 0. Got rid of our x values. Then I've got 3y minus 3y equals 0. So another situation where my variable again disappeared. And I get 45 minus 45, to be concise, is equal to 0. Another strange situation where both of our variables canceled out. And that is a situation that, obviously it can happen, right? But I don't have an invalid statement anymore. 0 is equal to 0, that's kind of true, right? It's not telling me anything false. If that happens, if I have a situation where all of my variables cancel out and I still get a true statement at the very end, it means that I have two overlapping lines. Remember, when we did slope-intercept, slope point form, standard form, general form, there's many different ways that we can write the exact same line. That's what's happened over here. We have two of the exact same lines. They're always going to be overlapping, which means you have an infinite amount of valid answers that you could use. Because we have an infinite number of points, it just means that both of our lines are overlapping each other forever. So this is another one of those weird situations. If you end up getting a valid statement but both of your variables cancel out, you have two overlapping lines. The other situation we had was previously over here where both of your variables disappear again, but we have an invalid statement. That means your lines never cross each other. Interesting way of looking at systems. You have to be aware that those can exist. A good idea is to practice a little bit. So I'm going to post some practice up so that you can get an idea of equations that do overlap, that don't overlap, whether they're parallel or whether they only have one exact point that we're looking for. And that will be the conclusion of systems. So you can expect some sort of assessment that includes all of your linear functions and systems all together. I'll post it up so that you have access to it online. And if anything comes up, feel free to give me a shout. We'll take things from wherever we're at.